If anyone is feeling confused or has no idea where to start, just let me know. Just ask for help. But otherwise, just give this question a try. Okay. So we started with this. Let me just turn my video off quickly. We started with this right at the end of our lesson on Tuesday. So don't panic if it's feeling a little bit overwhelming. But whenever we given a question, basically that sort of gives us information like this, it's kind of giving us a hint that they're wanting us to use Pythag. So I could write that tan 31, if it's equal to t, I could write that as t over 1. And remember that tan is opposite over adjacent. So think about your triangle, put in your angle of 31, then think about what side is going to be t, what side is going to be 1, and then you're going to need to use Pythagoras to find the other side. So you're going to need to use Pythagoras to find your hypotenuse. Okay, that's my advice on how to get started. And then once we filled in our triangle, the questions are not so difficult after that, because we can just look at them and see what to do. So first, see if you can fill in that triangle, get what you need into where it needs to go. If that bottom angle is 31 degrees, then this angle up here is going to be 59 degrees. So these are the things that we should start thinking about. Okay, for those of you who've just joined, we're just looking at a question that is similar to the one we did right at the end of our lesson on Tuesday, before we move on to identities today. And I've given you some helping hands on the right-hand side, and I'm wanting the answers to A, B, and C. I'm going to help you a little bit more by helping you fill in this triangle. If I know that tan 31 is t over 1 and that tan is opposite over adjacent, and that's my 31 degrees, my opposite is t, my adjacent is 1, and then I can use Pythagoras here to find that last side. Okay. From there, finding the answers for A, B, and C shouldn't be too tricky. Give them your best go. You can either write your answers in the chat, or you can let me know what your answers are. You can just unmute and talk to me. I'm happy with either. Try not to get overwhelmed with all of the questions. Just look at one at a time. So at the moment, just focus on A. Look at your triangle. Think about what sine is. So I'm just going to write them over here. So tan is opposite over adjacent. Cos is adjacent over hypotenuse. And sine is opposite over hypotenuse. And so using that, I want you to think, and looking at your triangle, what is sine 31 going to be? No takers. Okay, let's have a look. So in my triangle, if that's my 31 degrees, that would be my opposite side, that would be my hypotenuse, and that would be my adjacent. And so if I'm looking at sine 31, so this is for A, sine 31, I'm saying my opposite, which is t, over my hypotenuse, which is the square root of t squared plus 1. That's my final answer. That's all I have to write. That's everything. Okay, so now I've helped you with that one. Think about now what the 59 would be if we're working over here. So I'm looking at this angle up here. This would be my opposite. This would be my adjacent, and that would be my hypotenuse. So now try and find tan 59 for me. Yes, exactly. Beautiful. Tan 59 is going to be 1 over t, 100%. Well done. Good. And that would be my final answer. That's where I would stop. Now for the last one, we have to be clever because we've got this 121 and we don't want 121. We want the number to have 31. So how can I break that 121 up using our reduction so that this number here is 31? What's going to go to the left of that?
90 plus 51.
Yes, 90 plus 51. Good. Okay. And now that's one of our sneaky co-ratios. That's the one that becomes negative. So that's going to become negative sine 31. And I already know what sine 31 is. We worked it out in A, but now we're just going to put a negative sign in front of it. And that is our whole answer. So I promised we would do one more question like this in our lesson on Tuesday because we didn't get a time to spend a lot of time on it. I'm hoping it sort of makes a little bit of sense. Whenever you see a question like this, the most important thing, so as soon as you see something is equal to a letter like that, the most important thing is to draw your triangle and put the information in, use Pythagoras to find the third side. But only once you've done that, start looking at the questions. Okay. Does anyone need to sit on this page for any longer? Cool. Okay, so our lesson today, our last lesson today, is on trig identities. And it's when we have to basically, those of you who have already done this in class, it's when we have to prove that the left-hand side is equal to the right-hand side. We have to show that they are equal to each other. And so we have to play around with things that we know are true. Now, these are the two identities that we've learned so far. We know that tan is equal to sine over cos. We've dealt with that quite a lot in our lessons together. And we also know that sine squared theta plus cos squared theta is 1. This, though, has two other applications. So I could also move that sine squared theta over. So I could say cos squared theta is equal to 1 minus sine squared theta. And my other one is that sine squared theta could be equal to 1 minus cos squared theta. Now, what I'd like you to do, because we're going to be playing with these a lot today, is on a piece of paper somewhere that you can refer to often, I want you to write all three of these. So I want you to write that first blue one, these two, and I want you to write tan. So all of them together. And I want you to put them on a piece of paper that you can look at as we move through this lesson, because there's going to be times that I'm going to ask you what the thing is that we could change it to, and I want you to be able to tell me. So write this down somewhere that we can look at often before we move into the questions. Okay. Okay. Now this first one is really nice and easy. Ooh, sorry, moved down my page. I'm going to talk you through how we can look at a question like this and the setup that we're going to use. And then I'm going to let you try one that I'll try and give you some hints as you work through it. Okay. The first thing in any type of question like this is our left-hand side. So all of this to the left of our equal sign is called our left-hand side, and everything to the right-hand side is like that. Yeah, so sometimes co-ratios can be used to prove identities. It's quite mean though, so normally it actually only comes up in matric. So most of the time we try and avoid them, but they can come into a question. Okay, so we have our left-hand side and we have our right-hand side, and we have to try and prove that these two are equal to each other. Now, the thing that should be ringing in your head is this tan, because as you can see in our green block, tan theta is sine theta over cos theta. So we only choose one side that we want to work with. And normally, not all the time, but normally the easiest side to work with is the left-hand side. So I'm going to take my left-hand side and I'm going to say that's equal to sine theta times cos theta times tan theta. Okay. But I know that tan theta I can change to sine theta over cos theta. So we're going to show that change. Sine theta times cos theta times sine theta over cos theta. And now I can see that this cos and that cos cancel. And so what I'm left with is sine theta times sine theta, which is sine squared theta. And that is the same as my right-hand side. So our last step, we would say that is equal to our right-hand side. So that's the format. That's how these questions should look. We choose which side we want to work with. So like here, I've chosen the left-hand side. We write what side we're working with. We simplify it by using identities that we know. And sometimes we have to use factorization until we get to what we're looking for on the right-hand side. Okay. How are we feeling with this so far? Can you, yeah.
Ma'am, for the sine theta, cos theta times sin over cos, can we put the sin over cos in brackets?
You absolutely can. If you wanted to, you could 100% put that in brackets.
And then put the sine times cos over 1 to that.
Yeah. Also 100% fine. Do you have a question? No? Okay. Can we move on to the next one? Okay. All right. Let's have a look. So now that was sort of as easy as these can come. This is a joking thumbs up. Okay. This is as easy as this question can go. These are ones that you should be very excited about if you saw something like this. Sometimes proving identities can get quite nasty. We're going to see what we can do. Okay. So again, when you're looking at this question, I want you to focus on your left-hand side. Oh, I got a little bit overexcited there with that left-hand side. Okay, my left-hand side. I'm trying to get my left-hand side to look like my right-hand side. Okay, so we're working with our left-hand side. Yeah, okay, so how do you know which side to use? Pretty much I can say it 95% of the time, you're going to use the left-hand side. The only time you might want to use the right-hand side is if the left-hand side doesn't, like if there's a tan on the right or there's something that looks like it's easy for us to change, then we might go to the right-hand side, but 95% of the time it's left-hand side. So that's like normally I'll go to. Okay, so I've got cos cubed x plus cos x times sine squared x. And I said in our last question, you might have to think about factorizing in a question in these proving identities. What type of factorizing do you think I could do in a question like this? This is one term and this is the second term. How could I factorize something like that? Does anyone have any suggestions?
Isn't it when you pick out the
Yes, you're on the right track. What you're doing is you're going to take out your highest common factor. What you're saying is beautiful. Yes, well done. Yes, and in our comments, that was a double win. So we're going to take out our highest common factor. And in this case, our highest common factor would be cos. Okay, so we're going to take our cos. And I would be left with, from my first term, I would be left with cos squared x. And from my second term, I would be left with sine squared x. You don't have to use square brackets. I'm just a fan of square brackets. I think that they work nicely in trig. Okay, and now can anyone tell me, because this is something fancy, what is cos squared x plus sine squared x?
It's 1.
It's 1. So this is just cos x times 1, which is cos x, which is the same as our right-hand side. It's very, very like exciting when they come together and they just work. Okay. All right. Sorry? I'm not hearing you great.
Yeah, I'm saying, where did you get the 1 from?
Oh, okay. So I get the 1 because it's one of my identities. So I know that cos squared theta plus sine squared theta is equal to 1. And so because that's cos squared and sine squared, I know that it must be 1.
Oh, okay, thank you, ma'am.
Okay, no problem. Good, 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 good. Okay, so let's have a look at our next question. Oh, it's not like it's definitely necessary to write left-hand side and right-hand side, but whenever we can do something that makes the marker's life easier, we want to do it because then we're putting the marker in a good mood. And that means that they're going to be marking our work in a happy mindset. So if we can write stuff like that, it just makes it easier to do. You definitely don't need to put the left-hand side, right-hand side up there, but you should at some point say which side you're working with, and that is then equal to the other side. Okay. All about like managing your marker's emotions. My two who are unmuted, is that purposeful? Do you have a question? Okay. Okay, let's have a look at this next one. So on your piece of paper that I asked you to write in the beginning, where you wrote your identities down. Okay, so you wrote that tan was equal to sine over cos, and then you wrote those 3 different ones. I want you to look at them carefully, and I want you to tell me what this equals. Bokang, do you mind muting your mic for me, please? Thank you. Okay, so if I'm looking at that left-hand side, what could 1 minus sine squared theta equal?
Cos squared theta.
Yes, good. That is equal to cos squared theta. Okay, so if I'm working with my left-hand side, I'm just going to write out my first line. Okay, and I know that this whole first bracket is equal to cos squared theta. Okay, I want you guys to try and take this from here. Tell me where I could go next. What would be my next step in a question like this? What could I do? There's something that you should be seeing that we should change whenever we see it. Yes, change tan. Good. Okay. As soon as we see tan, we want to change tan. So I'm going to keep that cos squared theta, and I have 1 plus sine squared theta over cos squared theta. Good. Okay. That step's done. Now, I need to try and get this cos into my bracket. So I'm going to multiply that cos. I'm going to distribute it into both of my terms. Okay. So we're not doing anything fancy. We're just doing normal multiplication, normal distribution. So I get cos squared theta. And then that's going to be plus cos squared theta, sine squared theta over cos squared theta. Okay. What happens now? Remember, our goal is to get an answer of 1. What could I do?
And I'm not understanding this.
Sorry?
I'm not getting it. I'm getting you said you must multiply in the cos squared theta.
Yes. So, okay, so it's the same as like if I had 2 and then like, let's say I had x plus 3. So I had something and then inside I had brackets. All I'm doing is I'm multiplying that 2 into both of my terms. So I would have like 2x plus 6. So that's exactly what I'm doing here. I've taken this cos squared theta and I'm timesing it by 1, which gives me cos squared theta. And then cos squared theta, if you wanted to write it over 1, you could. So then that would be cos squared theta sine squared theta over cos squared theta. So we're just multiplying it into the bracket, like a normal distribution here. Okay, let's have a look at some of the things in the comments. Good, we can cancel the cos squared thetas in that second one. Good. And then what we are left with is cos squared theta plus sine squared theta, which is equal to 1, which is equal to our right-hand side. Okay. Can you give me a scale of 0 to 10, how you feel with identity so long? Still like early on in our lesson, so don't panic if your number is low. 0, you have no idea what's going on with identities. You feel completely lost. 10 is you're feeling great. Okay, good. Fantastic. Yes.
For the cos squared theta, the one that you multiply at the bracket, and here the 1 is going to times by the cos squared theta.
Yes. So the 1 times the cos squared theta gives me my cos squared theta. That's that first part. So when I multiplied this by the 1, then I got my cos squared theta. And then when I multiplied it by that, I got this.
But then, okay, so the cos squared theta multiplies only with the sin squared theta.
No,
Or is it like,
because
is the
when
cos squared theta for the whole fraction?
yeah, so when we have something that doesn't have a denominator, it would have a denominator of 1. So that would be the same as saying cos squared theta over 1 times sine squared theta over cos squared theta. And so then we multiply our tops and then we multiply our bottoms. Does that make a bit more sense?
Yes.
Okay. Okay, great. Thank you for asking. Okay, let's have a look. I'm going to see if I can leave you to try this one by yourselves. Remember, work with your left-hand side. And I want you to think my hint here, I'm going to give you one hint, is that 1 is equal to cos squared theta plus sine squared theta. That's my hint. And I'd like you to give this one a try. What's nice is that you know when you're right because it's equal to the right-hand side.
And this is quite fast, yeah.
Yeah, this one should be a nice, easy one. If you see it. The problem is if you don't see it, then it feels horrible because you don't know where to go.
Ma'am?
Yes.
Can I try?
Yes, please do.
Okay, so we got 1 minus cos squared theta, right? Over 1 minus sine squared theta, right? So we will transform our 1 minus cos squared theta to sine squared theta. Then we say and then we say over cos squared theta.
Mm-hmm.
So this sign or equation leads us to 10.
Beautiful. Which is our right-hand side. Yay! Well done. Ooh. Well done. Awesome. Okay. I'm going to get a little bit meaner now. We're going to slowly dip into the mean questions. Does anyone need to sit here? Can I move down? Okay. Okay. Again, think about your left-hand side versus your right-hand side. My advice with this situation is a little friend from grade 9 factorization called difference of two squares. What difference of two squares is? If I had x squared minus y squared, that would be x plus y, x minus y. That's my hint for this question. Let's see how you go. If you have multiple lines going on, something has gone wrong. This is just a 2-line question. Okay. So the silence is telling me that people are struggling a little bit, which is fine. I just want to then sort of pose you a question. So if this is difference of two squares, if I had x to the power of 4 minus y to the power of 4, what would my difference of two squares look like that? What would be in those two brackets? Oh, okay, sure. I can wait a bit. Yes, there you go. Okay, so that would be x squared plus y squared, and then x squared minus y squared. Okay, if you can do that, you can do this. Think about it in the exact same way. Wherever I had x, now it's sine. Wherever I had y, now it's cos. Think about what that's going to become. Remember, your right-hand side is always there to help you. It's like there is a guide. It's telling you what it wants. So I know that that has to be somewhere in there. Okay, so that's a great start of where you're thinking. Let's try and use this idea of x to the 4 minus y to the 4 and what that became into this. So if I did my difference of squares, okay, I can see that that's a square number, that's a square number, and this is a minus sign. So I know I can do difference of two squares. I'm going to have a plus and I'm going to have a minus. When I multiply these two together, I need to get sine 4 theta, which means this needs to be sine squared theta, and that needs to be sine squared theta, because then when I multiply them together, I'm going to get my 4. Then I'm going to do that exact same logic with my cos. Sorry, did my sound go funny? Sorry, Lisa. Okay, let me just re-explain this. Let me start from scratch. It'll probably help those who are not understanding anyway. If we're looking at our right-hand side is our guide. It's telling us what we want. So we know at some point, whatever is happening on there has to show up on the left-hand side. And if I use this logic here of this difference of two squares, I know that, okay, let's just write our question quickly. Sine 4 theta minus cos 4 theta. I know I'm going to have two brackets. I know it's difference of two squares because I have two terms. They are both squares and there's a negative sign. That's what tells me it's difference of two squares. So when I teach difference of two squares to my grade 9s, we write dots. And our way of checking if we can do difference of two squares, is there a minus sign for difference? Yes. Are there two terms? Yes. Are they both square numbers? Yes. So we can do difference of two squares. So when we do difference of two squares, we're going to have a plus and a minus. And then when we multiply those two together, we need to get sine 4 theta. So sine squared theta and sine squared theta will give us sine 4 theta. Then I need to think about my causes. When I multiply those together, cos squared theta, cos squared theta. Okay. And now, if you see, if we looked at our guide, our right-hand side, we have what the right-hand side wants. So we know we're on the right track. Then we just need to look at what we need to get rid of. And we have on the left over here, we've got sine squared theta plus cos squared theta. And what does that equal?
Don't we have to equal to 0 or something?
So sine squared theta plus squared theta is always going to be equal to 1. Yeah. And so then 1 times anything is itself, which is our sine squared theta minus cos squared theta, which is our right-hand side. And that's our final answer. Okay. So this is looking at difference of two squares in a little bit of a funny way. It's just tricky for our brains to think about it as difference of two squares because of the signs and the causes. It makes it difficult to see. All right. Okay. Our next one is a sneaky one. Because in this particular situation, you could work with the left, but because we have these tans chilling here, that's kind of like a sign to say, well, maybe we should work with the right. But you really can work with either. So both of them will work. I want you to give it a try. See, some of you may prefer to work with the left-hand side. Some of you may prefer to work with the right-hand side. Let's see how this one goes. If you need help or if you need hints, let me know. I personally think you will find it easier to work with this one. And you might also, I'm giving you hints that you haven't asked for, you might also find it easier to work instead of as a fraction, write it as a divide sign. So tan theta divided by 1 minus tan squared theta. I think that might help you. Remember your like go-to things that should help you. The first thing you're going to change, think of your tans. this might be one that we might want to work together through, like as a group. Can someone tell me let's say you were seeing this question in like a test situation and you had this yellow line written that I've got here. What would be the next step that I could do? So we don't know how we're going to get to our final answer, but we have to do something. So what could I do next?
Ma'am, can you repeat your question?
Yes, absolutely. So let's say we're in a test situation. We don't really know what to do, but we have to do something. What would be the thing that I would try and do from this yellow line? Where could I go next?
My answer will be we will have to change the tan to sine over cos theta.
Yes, absolutely. Okay, so as soon as we see a tan, our brain needs to think I need to change that. Okay, and that's a great start. So we can change this tan to sine theta over cos theta. Keep that as a divide sign. Yeah, exactly. Change the tan. And then in this bracket, we have 1 minus, well, if we want to write that as a fraction, 1 minus 1 minus sine squared theta, don't forget the square, over cos squared theta. Okay, great. We could change the sign to multiplication, but that might be yucky because at the moment our fraction is 2 different fractions. So what could I do to make these 2 fractions 1 fraction?
For the second side, for the other side, isn't it 1 minus cos squared theta over 1 minus cos squared theta?
Oh, no. So if I had, that would be if there was a square on the outside of the bracket. The only thing that's being squared is my tan. So the 1 stays itself. This one here is just this one here. And then this tan squared theta becomes the sine squared theta over cos squared theta.
Ma'am,
Yeah.
can I answer? Can I try? I
Yes.
think we have to take the sine theta over cos theta and times it with the other bracket.
We do need to times it with the other bracket, but what is that other bracket going to become? You're all saying absolutely the right things, but we first need to get this bracket, because remember when we have fractions, like if I had a quarter divided by 2/3, when I change this to a times, then that fraction flips. And at the moment, that fraction is a problem for me because it's 2 different fractions. So when I have 2 different fractions, like if I had 1 over 2 and I wanted to minus 1 over 4, what would you tell me I needed to do in that fraction situation? What would I need?
Okay, I'm still guessing, right, ma'am? We on our E equation, right? We had to we had sine squared 4 theta, right? And we had to split it up, right?
Yes.
To sine squared sine 2 squared, right? So I think this time we have to say sine 2 squared, right, theta, and then you have to in that point we have to open 2 brackets, right? For those 2 brackets is going to be sine. Honestly, I don't know what my point is.
No, what you're saying you could definitely do. You would just be making your life really difficult. So if I followed, so Marilyn, your answer in the comments is beautiful. We want to find a common denominator. But what you're saying is definitely not wrong. You could definitely split that into 2 brackets and say 1 plus sine theta over cos theta, 1 minus sine theta over cos theta. The problem is that you're just making your life more difficult than it needs to be. So from our comments that Marilyn's just said here, if we got a common denominator, if I got a common denominator of cos squared theta, okay, cos squared theta, I would need to multiply this 1 by cos squared theta minus sine squared theta. And now I have 1 fraction. So there's 2 really important things that you should be seeing in a question like this. Let's kind of just write them down as like important things to note. And the conversations that you're having and the questions and the suggestions that you're saying are perfect, because that is what Trig is all about. It's about problem solving. Okay, the first thing we need to see here, as soon as we see a tan, we know we need to change it to a sine over cos. Okay. The second thing is that if we have two fractions, like we had here, this 1/1 minus sine squared theta over cos squared theta, we want to combine them. And in order to combine them, we need a common denominator. Okay. So now I have one fraction. Now that I have one fraction, we can do what you were suggesting earlier and make it a times and flip that fraction. So now we can say sine theta over cos theta times cos squared theta over cos squared theta minus sine squared theta. Okay. So we are making progress here. Because like look at your right hand side. Do you see how close we're getting? We have this, we have that already. We're very close to getting that sine and cos. Now we're just in a place of looking at what can cancel. I have a cos down here and I have a cos squared up here. So I'd be left with a cos theta. Because if I have a square and I'm taking away one, I'd be left with just one. And then magically we have sine theta there times cos theta there all over cos squared theta minus sine squared theta, and that is equal to our left hand side. It's a monster. Are there any steps that anyone is feeling confused with in this question that you would like me to go over? It is a long question. Okay. All right. The next, the yellow cos theta. The yellow cos theta came because I cancelled this bottom cos theta, and then I had a cos squared theta at the top, so I was left with one cos theta because I had a square at the top and a normal one at the bottom. Okay, the next question has got very similar themes to this. So same things that you can like focus on. Think of the same things as changing tan. Think of the same things of combining to get a common denominator and get one fraction. And think, because I helped you here with this first line by writing it instead of a fraction as something divided by something, use that in this next question. Okay, so the next question combines everything that I've spoken about in this one. Let's see if anyone manages. Okay. Try your best. First step, break it up. Who can tell me what to write just for my first line? I'm not going to rush you guys. I just want the first line. What am I going to write?
Hey.
Hello.
For me, I took your first equation, right? I said tan squared theta divided by 1 plus tan squared theta, right?
Perfect.
Then my second step was sine squared theta over cos sine squared theta.
Beautiful.
And then I
Divided
said
by?
divided. Then I put the brackets you used to put the huge ones, the square root. And I said 1 over 1 plus sine squared theta over cos squared theta. So
Beautiful.
I'm still on there. I haven't finished yet. So
That's perfect. Well done. Now, for anyone who wasn't up there, we've got some help up there. That was great. That was perfect. Okay, keep going from there, guys. Combine those, get one fraction, change that divide sign. Who feels like they can help me in my next step? My hint is that it's going to be involving that fraction. Try to get a common denominator in that second fraction. See what happens. Oh, sorry. My screen has gotten a life of its own. Okay. So I'm going to keep this first fraction the same. Oh, yeah, Lisa, I can't hear you. I'm so sorry. Okay. Well, hopefully what I'm about to write is what you were wanting to tell us. Okay, so in this bracket, I'm now going to have cos squared theta plus sine squared theta all over cos squared theta. Close that bracket. That was my next step. Now I want to change that divide to a times. So sine squared theta over cos squared theta times cos squared theta all over. Now, this is where it gets interesting. What is cos squared theta plus sine squared theta? Isn't that something nice?
It's 1.
It's 1. Yes. Glorious. Okay. And so this cos squared theta and that cos squared theta cancel, and I am left with the glorious sine squared theta, which is our right-hand side. Yay! Okay, did anyone get this one? Did anyone get right to the end? Let me know. Either unmute yourselves or let me know in the comments if you were able to get yourselves to the end of this question.
I was able to get myself to the end.
Yes, well done. Give yourself a clap. Nice, good.
I forgot
Gr-
the plus.
Oh, that's okay. One step at a time, we'll get there slowly. Nice job, guys. Awesome. Okay. So we're gonna do, okay. The next one is a little bit nasty, and I've just seen our time is running low. So I'm gonna skip that one, and I'm gonna take us to this one. Okay. I want you to think about the stuff that we've spoken about. So again, work with your left-hand side here. Think about your factorizing. Think about your identities. And let's see if anyone's able to get to the end goal here. This isn't a really long one. Okay. I'm not telling you what to do. Think of this. Think of this. When I talk about identities, I'm meaning your identity of what equals 1 and what does tan equal. Those are what I'm talking about.
Ma'am, came late to class today, so can you like give me a hint of the identities? Because I'm lost.
Yes, your identities. The main one is that tan theta is sine theta over cos theta. And then your other one is that cos squared theta plus sine squared theta is equal to 1. And I can write that in different ways. I could also write cos squared theta is 1 minus sine squared theta. And I could say sine squared theta is equal to 1 minus cos squared theta. So those are the identities I'm talking about. Okay, we almost ready? Remember, it doesn't matter if you don't get the whole way. Think about this as like a journey, and you'll get sort of marks all the way down. Can someone guide me through what you decided to do in your first step? Just the first step. So when we looked at what we had going on here, what could I do? Yes, good. Take cos x out as your highest common factor. Cos x, and then I would be left with 1 minus, sorry, that's an equal sign, cos squared x. Beautiful. Okay, great first step. Bottom, what can I do in my denominator? So what can I do down here? Can I do the exact same thing? Can I also take out cos x as my highest common factor? Because I've got cos x in my first term and I have cos x in my second term. So I can take cos x out and I'd be left with 1 minus sine squared x. Now that should be ringing some bells for you because we can see that these two cancel and then our brains need to be jumping over here because what is 1 minus cos squared x? What does this equal?
Sin squared x.
Yes. And 1 minus sin squared x is cos squared x. And sine over cos is tan. And that is equal to our right hand side. How cool, how satisfying is it when it all just sort of comes together? Now, this is our last lesson together on Trig. And you're going to be going on to other Trig, just I won't be with you for it. My advice when it comes to Trig is don't be scared to make mistakes. A lot of Trig is problem solving, and sometimes you try something and it works, and sometimes you try something and it doesn't work. But the absolute worst thing you can do for Trig in your tests or exams is leave anything blank. So like, for example, this first step here, if you're looking at that and you're like, I have no idea how I'm going to get to tan. But if you can see, okay, well, I can take out a highest common factor, already you are sort of breaking down the complexity of the question and you're making it easier to work with. Okay, so with Trig, never give up, keep trying, keep problem solving, always keep your identities written on a little piece of paper next to you so you've got them in your exams and your tests and you can use them and you will all be absolutely fine. And I am going to pass the mic over to Nikayla, but it's been really nice teaching you guys and I'm going to miss you lots.
Hi guys. Yeah, it is quite sad. I'm sure I'm still going to be with you guys in the next series. I think I've been with you guys like for almost all the lessons, but I just want to say well done and thank you to Jennifer as well. I think she did an amazing job with teaching you guys. And yeah, all of you are doing really well. I always see in all the comments, like everyone starts getting the answers right a lot more. And I'm sure it's coming together for a lot of people. But for those, if it's not, I think in our future lessons as well, just keep asking questions. Yeah, I think that is like the key. So I'm going to share and yeah, you'll see that now we've come to the end, unfortunately, of the part A. And for your homework, it's a lot, but I think you can maybe work your way through it. So you're going to go to your topic as usual and look for trigonometry. And then you're going to go to proving identities and try to work your way through that section. So yeah, I'm just going to leave it up for all of you, or I'm just going to come back actually. But I wanted to also ask everyone, just out of interest, who would actually be interested in sharing like the Zoom link potentially for these classes so that your friends or people that you know or family members, cousins maybe, could also join in the Zoom sessions with you guys. So these lessons that you are having, who would be interested in, yeah, joining or having friends join?
I have friends who will be interested too.
Okay, cool. Yeah, we're just trying to gauge from that. I'm going to feed this back to our team. Okay. So you have quite a few of you have friends who would be interested in receiving the Zoom link and joining. Okay, cool. Thank you for that, guys. That's very valuable information. Okay, so yeah, we'll probably get back to you on that and a way forward on sharing that. But for now, we're just getting a feel. And yeah, I'm just going to go back to your homework so that you guys have it up before I leave. And yeah, thank you so much for attending. Well done to all of you for being so consistent. And I hope you enjoy the rest of your evening.